Hello, class. Welcome to our lesson today. We're going to be looking at a lot of different topics, kind of like a review of just some different things that we've done, along with some things with ratios today for our Chapter 10 opener. Chapter 10 is going to look at probability and a lot of things with fractions and simplifying and making sure we can predict things. So we'll look at those things as we move into Chapter 10. Before we get too far, though, let's do a few ratio and or rate situations. There's a lot of information here. We're going to use the same information on multiple slides. So at this carnival this school is having, there's 8 food booths and 12 game booths. There's 55 adults, 165 students that go to the event. $1,100 is raised at the carnival in total, and of that 1,100, 700 came from ticket sales. And then we're just trying to find the ratio as a fraction in simplest form. Now remember, a ratio could be written with a colon, okay, kind of like what's given here. It could use the word or it could be written as a fraction. The only reason you'd have to write one in a particular order or type is because the directions say so. So these say fractions in simplest form, so you'd have to use that idea. First one is students to adults. So there's 165 students, 55 adults. And then from here, it's just a simplified question. You may have to divide by 5 first off. Both of these actually divide by 55, and it works out perfectly. And this will end up being 3 over 1 as the final ratio, the ratio of students to adults. Adults to non-ticket money, 55 to 400, because there was $1,100 minus the 700 from ticket sales. And simplify that down, that's 11 to 18. The next one is the number of booths to money raised. So there was 20 booths total because 8 food booths and 12 game booths, and then divide by the 1,100. The nice thing here is you can cancel out some zeros. You get 2 over 110. It becomes 1 over 55. This situation actually is kind of nice because it shows for every booth there's about $55 worth that come in. Obviously, a lot of that comes from the ticket sales, but that gives you a good idea about how much money would come in per booth. Ticket money to total money would be a 7 over 11 because it was 700 over 1,100. Again, that could show of all the money, how much of it came from ticket sales, and that's what you would be showing there with the 7 out of 11. Number of booths to number of people. This involves adding a few parts. So the 8 plus the 12 is 20. 155 plus 55 plus 165 is 220. Simplifies down to 1 over 11, which shows there's one booth for every 11 people. If you're thinking about how to space everyone out, or how many booths should we have, that might give a good idea for that situation. Food booths to game booths, it'd be 8 to 12, which simplifies down to 2 to 3. So really, all of these questions are just simplifying ideas. You just got to make sure that you're able to do that. And make sure you add when needed. You may have to subtract it at times to find the number that you're looking for. But there's a lot of different forms of questions that can be asked just by this one paragraph. So that's a good example of one of something you might see in the future. Next thing I want to talk about is just mean, median, and mode. We're going to talk a little bit more about mean, median, and mode later in the semester. But remember, mean is the average. And so if I add up all these numbers, I just add them all up, I get 131. And then divide by 10 because there's 10 numbers, and I get a mean of 13.1. Remember, to find the median, you got to order the numbers from least to greatest, so I did that here. And then I don't know if you do this, but I kind of count from the outsides and work my way to the middle. And since this has 10 data points, there's going to have to be an average of these two middle numbers, which is 12 and 14. So the median then it would be 13. The mode here is 15 because it's the one that occurs most often. It is true that 9 occurs twice, but 15 occurs 3 times, so you have to use that as the mode as opposed to the number 9. Next review topic is just the idea of a unit rate. Remember, a unit rate is the price for one of something or the amount per one. And so if this is 1680 megabytes in 4 minutes, just take 1680 divided by 4 and you get 420 megabytes per 1 minute. This one is more common in like things like a deli or unit rates at a grocery store. $1.12 for 8 ounces. If I take $1.12 divided by 8, that's 14 cents an ounce. This is the idea of things that are written on grocery store tags. If you've ever gone in there and looked at the unit rate prices, and you can compare unit rates very quickly because of the tags being set up like that. But you want to make sure that you're able to find that because sometimes when things are on sale, they don't put the unit rate on there every time. The next one is finding scale factor. Now, scale factor, remember, is the scale is 6 millimeters to 20 centimeters. The scale factor then gets rid of the units. Okay, so the units here are millimeters to centimeters. So I'm going to change the centimeters to millimeters by multiplying by 10 because there's 10 millimeters in every 1 centimeter. That gives me a ratio or a scale now of 6 millimeters to 200 millimeters. The units can cancel because they're the same. And I just simplify that down and it's a 3 to 100 ratio, which is the scale factor then. Similarly, on the second one, I have 6 inches over 3 feet. The 6 inches is good to go. I change 3 feet into 36 inches by multiplying by 12. This simplifies down to 1/6. Now, both of these, notice, are smaller number over larger number, which means the model or the scale is smaller than real life. If it were inverted, then the scale would be larger and the real life would be smaller. But the key for scale factor is that the units have to cancel out. Another topic to discuss is percent of change. Percent of change, remember, is how much changed and then divided by the original. This is from chapter 6 in your textbook if you're trying to find a spot for that. I find the difference between 53 and 40, that's 13. I divide by 40 because that's the original amount. I get this 0.325. Now, sometimes it doesn't work out nicely and that decimal keeps going on and on and on. Typically, you round to the nearest tenth of a percent. When you do that, you'll move the decimal 2 spots over to the right, multiplying by 100. Make it the percentage, then round to the nearest tenth. This is also an increase because it goes from a smaller number to a larger number, and so this would be a percent of change that's an increase of 32.5%. Graphing inequalities, there's a few things that you want to make sure of. Number one is open and closed circle. So this definitely is going to have an open circle when I solve it because it's just a less than symbol, which eventually will become a greater than symbol, because the second thing we need to remember is when we have a coefficient that's negative, like this -3 right here, I'm going to have to flip the sign. So I solve this just like an equation. To get rid of +9, I'm going to do -9 on both sides. -3x is less than 12. I'm going to divide by -3 on both sides to get rid of the coefficient of -3. When I do that, though, remember, make a note to yourself, whenever you multiply or divide by a negative, you flip the sign. So this would be x greater than -4, and the idea is because a negative times another negative will become positive. I have an open circle at -4 because it doesn't have the equal to, and I want greater than, so that would be area to the right, because you're looking for numbers that are higher than -4. For your homework, there's some overlap to what we just discussed, but some other things that you want to make sure of. There's a lot of questions about multiplying fractions. Don't forget you had to make things improper first, and then don't forget you can cross-cancel. This is not a cross-multiplication idea because it's not fraction equals another fraction. It's just multiplying, so you can cross-simplify and things like that in order to find your answer. Percentages from chapter 6, the part equals percent times whole, or you could do the proportion idea. There's again some more practice on that. We just talked about one inequality about flipping the sign, but you have some questions that deal with inequalities as well. And then there's some interest questions. Remember, interest, simple interest, is the principal, which is the initial amount, times the rate, which you have to make a decimal. So if it's 7%, that's 0.07. And then times the time, but that has to be in years. So if they give you 6 months, you got to make sure that's 0.5 years. I know there's a lot of different topics here. These are all things that we've kind of done throughout this school year so far. It's just to kind of get us into some fraction modes and to review some of those topics to get ready for Chapter 10. Have a good day, everyone.